Hello everyone. Now we shall look at the second operation which we applied on deterministic finite automata. The second operation is concatenation. Before this we already discussed the union operation. So in concatenation operation, suppose a language L1 have DFA D1 and language L2 have DFA D2. When you applied the concatenation on both the languages L1 and L2, that means applied concatenation on D1 and D2, then the resultant will be L1 dot L2, which is D1 dot D2. It means in the transition diagram, the diagram will look like this. Transition state, let's say this represent D1, and then after we draw D2. So in transition diagram, the transition states of D1 and D2 will one after the other. While in DFA, the transition diagram will look like this: D1, and on the downside we draw D2. So this is applicable in union operation and this is applicable in concatenation operation. Okay, so let's take an example. It will be more meaningful to understand the concept. Let us say I have a language L which starts with A and ends with B. Okay. So it is very much different from the language which we discussed previous. In previous video we discussed a language which starts and ends with different symbol. So this language will be a one part of the previous language. Okay, so it comes under the category of concatenation operation. So what will you do? We will first draw the first part of the language and then draw the second part of the language, and then after we will merge these two subparts and make a whole language which will look like this. Okay, so starts with A. First we draw starts with A. So the initial state is, let's say, capital A. If I see a then I will go to the final state capital B, and on capital B I will accept any number of A's or B's. Okay, and if I see small b on the initial state itself, then I will go to the dead state C and I will reject the particular string. On that state I will take any number of A's or B's, it doesn't matter. The second part is ends with B. For ends with B, I will draw the transition diagram. Capital A is the initial state. Okay, if I see a B, then I will go to the final state, and on final state I will accept any number of B's but not A, any number of B's. If I see a on the final state, I will move back to the previous state capital A and I will accept any number of A's. On initial state I accept any number of A itself because it will not harmful for for the language. So language criteria is it ends with B. That's why I will draw the transition diagram. Look like this. Now after drawing the two subparts, I will merge these two subparts and make the final language. So there is not enough space here. What I will do here, I will make some correction in the transition diagram here itself and give you the resultant diagram. So it is our starts with A. I will just add, because in concatenation after DFA D1, the second DFA D2 is added here. So here it starts with A and then any number of A's or B's. Let's say I have removed this B and add here, and I will go to the final state capital C, where I will end with any number of B's and if I see n in A, then I will move back to the state capital B. Okay, so this is the final diagram of language which starts with A and ends with B. So what I will do here, I will draw the DFA1 and then concatenate the DFA2 with this DFA1. Okay, so it starts with A, reject B starting from, and then ends with B. If you see A, then we'll move back to the previous state. Okay, now in the next video we will see the third operation on DFA.